Hi friends, welcome to the next part of analog electronics. So we are learning the basics and fundamentals of bipolar junction transistor through problems. I hope you all understood whatever the things that we did so far. So let us take few more problems and try to understand this subject in better way. It's time to solve problems by yourself. Almost I have given all the basics ideas. So hereafter, don't expect the solution from my side. Try to solve it by yourself. Okay. So let me try to bring the first question here. So the question number one is 1 minute. The circuit shown in the figure. Question is the circuit shown in the figure supplies power to an 8 ohm speaker supplies power to an 8 ohm speaker. It's supplying the power to an 8 ohm speaker. The value of ICE and VCE for the circuit. Actually, the question is find the operating points of the circuit. Operating points are dash. Operating points means who are all considered as operating points. I hope you remember, so I'm not going to tell you. Try to figure it out by yourself. Already we have been discussed about this point many times, that is called operating point. Just recapture. Operating point means what? Who are all considered as the operating point. So here the given voltage is minus 15 volt at this terminal, and here we are joining these two terminal. Here it is given as plus 15 voltage, and they are calling it as transistor Q1 and this is Q2, and it is mentioned that this is IC and this is collector to emitter voltage VCE. Then where is that speaker? They told that speaker is connected at this point. It is connected with the ground. Its internal resistance they told that is 8 ohm. This is called speaker. See, first of all, I would like to tell you something. Operating point means it is nothing but collector current and collector to emitter voltage. Now they have highlighted here. There are two transistors, but you can guess. So they have given two transistors here. So one transistor is carrying the current is called collector current and collector to emitter voltage. Both is already highlighted. So just you have to bring the answer for these two people. Find the value of collector current and collector to emitter voltage. Now your time starts. Try to figure out the answer for this question. What can be the expected answer for this question? Just try yourself, get some idea, try to get some idea. If you are very good in basics, then it will be sufficient. You can easily figure out the answer. Okay, fine. You might have some idea applied on this. Let me try with the basic knowledge. If you clearly focus the circuit, they have given a current source here. Yes, sir. First thing, and they have given two different type of transistor. Did you notice or not? First one is, just observe transistor Q1. I'm just drawing it separately. Transistor Q1 has been highlighted like this. So they have drawn the transistor, everything they did. What happened is they have reversed the direction of current. And it is tilted. What is this? First of all, in a transistor, we have to identify the emitter terminal. That is the first terminal that can be easily identified. Now tell me, where is emitter terminal? So here, this terminal is called emitter. Now tell me why I have chosen that terminal as emitter terminal. How it can be chosen as emitter? I always told that across the emitter only the direction of the current will be highlighted. So in this transistor, the direction of the current is highlighted already. So by taking it as a reference, I just identified the emitter terminal. And the second thing is, if the direction of the current is towards the transistor, if it is towards the transistor, then that is called what? PNP transistor. Yes or no? Yes, sir. First conclusion. Similarly, if we take the second transistor, let me draw the second one. Second one also they have highlighted in the same way, but when I was focusing the second transistor Q2, just keep your attention with the second one. This is Q2, this is Q1. They have mentioned it. Already names were highlighted here. So Q2, how it is represented? See the direction of the current is highlighted outward. How will you identify it? Sir, if the direction of the current is outward, then what is this? First of all, identify the current position. So this terminal is called the emitter terminal. And the second thing is, according to the direction of the current, if the current is going outward, then the transistor is called NPN transistor. So we are having two transistors here. One is PNP, another one is NPN transistor. Now, if you little bit keep your attention internally, if we focus the transistor, I told usually we are designing the transistor with the help of PN junction diode. PN junction diode. How will you draw the PN junction diode? You know how to draw the PN junction diode. Wherever we have P, that will be considered as anode. N will be considered as cathode. So this is PN junction diode, and this will be treated as anode, this will be treated as cathode, and its equivalent circuit in forward bias. When we take the forward bias, P will be replaced by positive plate, N will be replaced by negative plate, and its voltage drop plus minus 0.7 voltage. Do remember, I have been told you that though it is not given in the question, it doesn't matter whether they are giving the data or not giving the data, you have to take it because it is practical circuit. So always replace the diode in its forward bias by its correspondent cutoff voltage 0.7 voltage, that is the equivalent circuit of the PN junction diode. Now if we draw the internal circuit of this transistor, how will you highlight this? We know how to draw the diode for this. In case of let me draw first NPN transistor, the diode will be back to back connection, it will be like this, we know that. But if we take PN junction, the diode will be there also, it is back to back only, but that connection will be like this. It is opposite to NPN transistor. And the next thing is, since we are trying to operate our transistor in active region, next conclusion, we are always trying to operate our bipolar junction transistor in active region. It is also called linear region. It is also called linear region. Yes, sir. So if we are trying to operate your transistor in the active region, then it doesn't matter whether it is NPN transistor or PNP transistor, always emitter junction will be in forward bias, collector junction will be in reverse bias. It is general. So we must apply this. So the conclusion is, we no need to be bothered about the collector junction. It is in reverse bias in active region. You are focused only with the emitter junction. Where is emitter junction now? In case of PNP transistor, this is the emitter junction. In case of NPN transistor, this is the emitter junction. So here I can replace this diode by its correspondent source, that is equivalent circuit, forward bias. You know how to do that. 1 minute. Now I am replacing the diode. Now we understood that the emitter junction diode will going to be operated in forward bias. So we are going to replace it by, sorry guys, its correspondent equivalent DC. How will I do that? This is negative, this is positive. Emitter to base, and its drop is 0.7 voltage. Similarly, if we keep our attention with the second diode, that is NPN transistor, I have kept the equivalent circuit for PNP. Now for NPN, we know the direction of the diode. P will be positive, N will be negative. It will be represented like this, plus minus 0.7 voltage. It is very important. So why I am discriminating like this? If you are very clear with this, then while solving the problem, it will be very easy. So now we understood all the basics. Yes, sir. Now it's time to explore the value of collector current and collector to emitter voltage. Shall we start? Yes. Let us take the same circuit. Where is the circuit now? This is the circuit. Come to the circuit. Let us start evaluating all these things. Yeah. So here, see, first one is NPN transistor, Q1, sorry, PNP. Q1 is PNP, right? PNP means, and we identify the emitter junction also. Across the emitter junction, can I replace the circuit like this, plus minus 0.7 voltage? Similarly, for the NPN transistor, Q2 is NPN transistor, we identified. For this, we can replace it by plus minus 0.7 voltage. Here also we have 0.7 voltage across the base to emitter junction. Now, can you please let me know what can be the expected voltage here? I'm just highlighting some point just to focus at this point. I just wanted to know the voltage at this point. I'm calling it as Vx. I just wanted to know the value of Vx. How can we identify it? If you keep attention with the base terminal, what is the value of base voltage here? VBB. What is the value of VBB? VBB is 0 or not? The value of VBB is 0 voltage. Why, sir? Because it is connected with the ground. If it is connected with the ground, then how will you do that? Ground means its correspondent voltage will be 0. Okay, sir. So I'm just taking the transistors separately. Clearly focus on the circuit one more time. So they have clearly told this is emitter junction. I just wanted to know the voltage at this point. We can cross this terminal, we know. So this is plus minus 0.7 voltage. It is connected with the ground. So if it is connected with the ground, this voltage is going to be 0. Here I just wanted to know the value of Vx. How will you do that? Vx means that is plus Vx only. I'm just assuming that is plus Vx. How will you do that? So if I will redraw this circuit like this, can I draw? See, I'm starting from ground. First base terminal is connected to the ground. Then I am crossing the diode. Diode will be written like this. Then I am reaching one more voltage that is called Vx. Here we are having 0 voltage. This is minus plus 0.7 voltage. Simply apply a potential difference. According to, while always finding the potential difference, see, positive plate is connected with this node. Negative plate is connected with this node. Yes. So we have to subtract from positive plate node to negative plate node because the subtraction should be higher potential point minus lower potential point. So in the higher potential point, the voltage, what we are having here, Vx minus lower potential point is connected with the ground, 0 equal to, what is the voltage? Potential difference between these two terminal will give you the voltage drop of that particular branch. That will be 0.7. So what is the conclusion here? So the conclusion is the value of Vx also going to be 0.7 voltage only. That is the first conclusion. Yes or no? Any mistake here? No, I did not do any mistake. I have been observed that there is one diode. Across the diode, 0.7 voltage will be there because it will be in forward bias. The another terminal of the diode, this diode is connected with a particular branch. It is having two terminal. One terminal is having some unknown voltage, another terminal is having zero voltage. See, இது நீங்க practically எப்படி சொல்லுவீங்க? ஒரு பாக்ஸ் இருக்குன்னு வச்சுக்கோங்க, unknown பாக்ஸ் கூட நம்ம சொல்லிக்கலாம். இந்த மாதிரி இருக்கு. இங்க பாத்தீங்கன்னா இங்க வந்து ஃபார் an எக்ஸாம்பிள் இதான் வந்து பையன். ஓகே, he don't have any, இவர்கிட்ட எந்த காசுமே இல்லை. ஆனா திடீர்னு பார்த்தா இவரோட பாக்கெட்ல வந்து செக் பண்ணி பாத்தீங்கன்னா 1000 ரூபி இருக்கா. இங்க பார்த்தா அவங்க அப்பா நின்றுட்டு இருக்காரு. ஆப்போசிட்ல கீழே பாக்குறீங்க, இங்க யாருமே இல்ல, நில். இங்க இங்க காசு கொடுக்கறதுக்கு யாருமே இல்ல. இப்ப இவர் தான் ஃபாதர், he is the son. இப்ப நீங்க என்ன பண்ணுவீங்க? ஒரு வெளியில இருந்து ஒரு அப்சர்வரா நீங்க பார்க்கும்போது இவ்வளவு நேரம் இவன்கிட்ட காசே இல்ல, திடீர்னு இப்ப இந்த இடத்துல பார்த்தா 1000 ரூபாய் அவன்கிட்ட வந்திருக்கு. அப்ப அந்த 1000 ரூபாய் யார் கொடுத்திருப்பா? கண்டிப்பா அவங்க அப்பா தான் கொடுத்திருப்பாரு. So this 1000 rupee came from his father. அவ்வளவுதான். அப்ப இந்த 1000 ரூபாய் இங்க வந்தது காரணம் அவங்க அப்பா தான். That's all, very simple logic. இப்படிதான் நம்ம வோல்டேஜ் டிவிஷனும் அப்ளை பண்றோம். ஸோ இங்க Vx அப்படிங்கிற பாயிண்ட் தான் ஃபாதரு. அதுக்கப்புறம் கிராஸ் பண்ணும்போது பார்த்தா இங்க 0.7 வோல்டேஜ் வந்திருக்கு டயோடுக்கு. அதுக்கப்புறம் பார்த்தா 0 வோல்டேஜ் வந்திருக்கு. அப்ப இந்த 0.7 டயோடு வந்து ஒரு பாசிவ் எலிமெண்ட். அதுக்கு வந்து டைரக்டா வோல்டேஜ் யாரும் கொடுக்க முடியாது. சாரி, அதுவே வந்து ஜெனரேட் பண்ணாது. இட் வில் டேக் தி வோல்டேஜ் ஃப்ரம் சம்ஒன். So it has taken the voltage 0.7 from someone. That someone is nothing but Vx. So what we understood is the available voltage at this node. I have highlighted some point. Now at the marked point, the available voltage is 0.7 voltage. Yes sir. Now see there, that 0.7 voltage will be available till this point. I can take the same voltage here, I can take the same voltage here, I can take the same voltage here. Till this point I can take the same voltage. Now it's time to explore the value of voltage at this point. Let me call this voltage is Vy. Sir, how you are thinking like this? Practice. When you are continuously practicing, automatically you will get the idea. ஏதாச்சும் ஒரு க்ளூ கொடுத்துருப்பாங்க, இது எப்படி கண்டுபிடிக்கிறதுன்ட்டு. நம்ம ஏன் சார் நார்மலா இதுக்கு முன்னாடி KCL KVL போட்ட மாதிரி போடல? ஏன் அப்படின்னா நடுவில் வந்து ஒரு கரண்ட் சோர்ஸை கொடுத்துட்டு அந்த கரண்ட் சோர்ஸ்க்கு வேல்யூ கூட அவங்க கொடுக்கல. திஸ் இஸ் ப்ராக்டிக்கல் கரண்ட் சோர்ஸ். இன்டர்னலா அதுக்குள்ள சம் ரெசிஸ்டன்ஸ் இருக்கும், அதுல ஒரு வோல்டேஜ் டிராப் இருக்கும், எதையுமே நம்ம ஃபைண்ட் பண்ண முடியாது. So now I can't apply KVL in this way. Is it possible? No. Since the value of current is unknown, what will you do? Without knowing the value of current, you cannot identify the value of internal resistance, voltage. Nothing we can do here. That's why I have avoided this method here. Nothing. This is not called a method. I'm not going in that way. because I can't cross this current source. Without knowing its property, I can't do anything. So I have started thinking in the alternative way. அப்போ இந்த கரண்ட்டை கண்டுபிடிக்கிறதுக்கு எந்த க்ளூவும் இல்லை அப்படின்னா இந்த கொஷினை பிரேக் பண்ணுறதுக்கான another க்ளூ என்ன? அதுதான் இங்கே டைரெக்டாக கொடுத்துட்டாங்க. இந்த கிரவுண்டில் கனெக்ட் பண்ணி டயோட வோல்டேஜ் கொடுத்துட்டாங்க. சிம்பிளி நம்ம கேவிஎல் அப்ளை பண்ணி சால்வ் பண்ணுறதை விட இன்னும் ஈஸியாக கொடுத்துருக்காங்க. ஃபார் யுவர் அண்டர்ஸ்டாண்டிங் ஐ எம் ஸ்பெண்டிங் திஸ் மச் டைம். But in practice, even it won't take 1 minute. Okay, sir, fine. If it is 0.7 voltage here, I hope now you can easily identify the value of Vy. See there, you know again here 0.7 voltage is there. What can be the expected voltage? Start panlama. Now, let me draw the second diode. Let us keep our attention with the second, not diode, transistor. Now, I am focusing at this point. You know, this is across this we have one more source, not source, diode cut-in voltage, and this is the base terminal. This terminal is having 0.7 voltage. How can we redraw this circuit? So let me draw like this. So here I am having 0.7 voltage, here I am having, so from this I am just starting. After that we are crossing that diode. Diode will be having plus minus 0.7 voltage. Then we are reaching the another junction. In that junction I am highlighting the voltage point is Vy. I don't know that value, but here I know this will be 0.7 plus 0.7. Now tell me, how will you identify the value of Vy? Can I say like this? Once again I told you, observe the resultant polarity. See, positive plate is connected here, negative plate is connected here. It means how will you subtract? We have to, higher potential point will be having positive plate. Internally in the branch la nadula drop ஆயிருக்க voltage ஓட positive plate எங்க connect ஆயிருக்கோ அதான் higher potential point. Opposite இருக்குது lower potential point. அப்ப இந்த higher potential point ல இருக்க voltage lower potential point ல இருக்க voltage subtract பண்ணீங்கன்னா you will get the voltage drop of that particular branch. So that will be 0.7. So from this let us see, I can further expand this. Higher potential point is having 0.7 voltage minus lower potential voltage is Vy equal to 0.7 voltage. From this the value of minus Vy equal to, if I will pass this 0.7 to the right side, what I will be getting? 0.7 minus 0.7. What is this? Sir, this will be equal to 0. No sir, 1.4. Really? No, it is 0 only. We got 0. So there is no significant sign for 0. So Vy equal to 0 voltage. Finally, we found the value of Vy also. Go back to the circuit. So this will become 0 voltage. And one thing I just wanted to tell you, while solving the problem, if you are very sure about your solution, you are going in correct method. If you are getting some negative value or 0 value, whatever the value that you are getting, simply apply and continuously solve the problem till the last point. What some people used to do is they will be solving 2 or 4 steps. When they are getting some negative value or 0 value, suddenly they will be thinking how it is possible. என்னவோ டிரான்சிஸ்டர் நீங்க தான் மேனுஃபேக்சர் பண்ண மாதிரியோ அது இப்போ அவுட்புட் வந்து தப்பா வந்திருக்க மாதிரியோ உட்காந்து ரிசர்ச் பண்ணிட்டு இருப்பீங்க. நீங்க வந்து கண்டுபிடிச்சிருக்க வேல்யூ கரெக்டாக தான் இருக்கும், பட் உங்க மைண்ட் என்ன பண்ணிட்டு இருக்கும், நோ 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 இட் இஸ் நாட் பாசிபிள், இது எப்படி 0 வோல்டேஜ்லாம் வரும், கொஸ்டின் இந்த மாதிரிலாம் கொடுக்க மாட்டாங்க. அந்த டிரான்சிஸ்டர் டிசைன் பண்ணவங்க கூட அந்த மாதிரி பண்ணியிருக்க மாட்டாங்க. நீங்க அந்த மாதிரி உட்காந்து அதை ரிசர்ச் பண்ணி அது ஒரு புது டிரான்சிஸ்டரா மாற்றி விட்டுருவீங்க. So don't do like that. Whatever the answer that you are getting, drive பண்ணும்போது என்னென்ன வேல்யூ வருது, just strive with that value. Don't try to stop anywhere till the last point. Final answer வரல அப்படின்னா that case will be different. Then you can recheck. But in mid while solving the problem, ஐயோ லென்த்தியா இருக்குது, ரொம்ப பெருசா போகுது, இதை பண்ணணுமே அதை பண்ணணுமே, இது எப்படி நான் பண்றது, these kind of unwanted activities also will push you to stop getting good score. So don't do this kind of activities. Fine sir. Anyway, we got the voltage at this point, 0 voltage. Now what can I do, sir? I think this resistor value is given in the question. 1 minute. I haven't noticed it properly. Sorry guys, I forgot to give this value. Yeah, this is given. This is also 8 ohm only, they told. Now see there, what is the voltage at this point? Vy. Just now we found that the value of Vy is 0. And what is the voltage at this node? Here. Minus 15 voltage, it is given here already. Yes sir. Now how will you identify the current flow? See, now it's time to explore everything. What we are going to explore now is we are going to identify the current flow through this branch. Yes sir. It is very easy to identify it. Yes, that is what we are going to do now. And from this, we will explore other things further. We need to know the value of collector current and collector to emitter voltage only. So whatever the data that is given, I'm just trying to figure it out with the way that is given. See there, I'm just drawing that. Let us go to next page. What happened is they have given that 8 ohm resistor. It is connected with the minus 15 voltage, and here we saw that the value of Vy is 0, and here we have 8 ohm resistor. Now tell me the direction of the current. Current will always flow from higher potential point to lower potential point. First conclusion. This is how we are identifying the direction of the current. Now if you observe, here we are having 0 voltage, here we are having minus 15. Which is high voltage here? 0 voltage is always greater than negative value, minus 15. So comparatively, this point is called higher potential point, this point is called lower potential point. So this will be the direction of the current, downward. Next, resistor is a passive element. So for the passive element, current entering point plus leaving point is minus. Now what can be the voltage drop across the 8 ohm? To know the voltage drop across this 8 ohm resistor, let me call it as Vp. What we have to do? Find the potential difference between higher potential point minus lower potential point. Higher potential point is carrying 0 minus lower potential is carrying minus 15. So minus of minus will become 15 voltage. See, this minus came from the source they have given. This minus according to the definition. Don't get confused. So the voltage drop across the 8 ohm resistor is 15 voltage. Now, can you please let me know the current? Suppose if I am calling this current is IP. What can be the expected value of current IP here? The value of current IP is going to be voltage drop across the resistor divided by resistance value. So I can say 15 by 8 ampere is going to be the value of what I can say resistor current through the circuit. Current through this particular branch. Can I say like this? Yes. Now, if we cancel this, what will be getting? 1 8 will become, remainder will be 7. Again, we have to cancel. I think it will be 8 times 64. Remainder 6. Yes, 1.875 ampere is what I am getting here. That is the value of IP. Fine, sir. That is what we got. Next, what we have to do. See there. Now it is very easy to explore the circuit. For your understanding, I am separating in the transistor மட்டும் நம்ம இப்ப தனியா வரையலாம். Just for your understanding, I am doing this. We have to observe the circuit. See, upper terminal, that is collector terminal. Then we have the transistor. So here they kept one 8 ohm resistor. It is connected with the minus 15 voltage. We know the current flow through this resistor now. Through this resistor, the amount of current flowing is 1.875 ampere. Resistor value is 8 ohm. But what they did is, from this terminal, they have taken one more branch, and that is connected with the ground here. Yes, they are treating it as a speaker. So they told that the internal resistance of the speaker is 8 ohm. That is what they told. Now, how will you identify? Our target is we must know the value of collector current and collector to emitter voltage. Almost we are getting close to the answer. On this top of this terminal, they also given this voltage 15 voltage. Now we know in this base we are having 0.7 voltage. Across this terminal also we are having 0.7 voltage. Everything we know. And here we are having 0 voltage. We identified all these things. Can you please explore now? Try this. See, here we are having 0 voltage. This ground also having 0 voltage. Now we know this is called emitter current. The current that is coming out of the emitter, that is called emitter current. And this is NPN transistor. You all know the direction of the current. So I can say like this: the current flowing through the speaker, I am calling it as speaker current IS. The current flowing through the 8 ohm resistor, already I kept the name, that is called IP. If you apply KCL at this junction, it will be clearly telling us that the value of emitter current will be equal to the addition of speaker current plus current flowing through the 8 ohm resistor. I am calling it as IP. We know one current here, current flowing through the 8 ohm resistor we know. But now it's time to explore the current flow through the speaker. How will you do that? For that, I'm taking the speaker and I'm drawing its equivalent circuit. They had given only one data about the speaker, that the internal resistance of the speaker is 8 ohm. So electrically I'm replacing it by its correspondent resistor, because I just wanted to know the current flow. On the top, what is the voltage here? Can you please tell me? This is 0, sir. See, they only told. We have identified this voltage. If here it is 0, then here also it is 0 only. So on the top of the speaker, we have 0. Bottom, bottom is connected to the ground. So that is also carrying 0. Then what can be the expected value of current here? Now here there is no higher potential, there is no lower potential. Just to find out the speaker current by subtracting 0 minus 0 by 8 ohm resistor according to Ohm's law. 0 minus 0 will be 0. 0 by 8 will be 0 only. So the conclusion is current flow through the speaker will be 0 ampere. We found the value of current flow through the speaker, that will become 0. So the conclusion, the value of emitter current can be written as speaker current is 0, whereas current flowing through the 8 ohm resistor is 1.875 ampere. So what can we say? Emitter current equal to 1.875 ampere. Okay, sir. I just wanted to ask you some other question. Is there any data in the question to calculate the value of base current IB? Because I know the value of IE. Now I have to target, I have to achieve the value of collector current IC. We know IC equal to, I cannot directly write IE, right? IC equal to alpha times of IE. But do you remember, in any question, if there will be no any data about base current or beta, if they have not given any data about this, what I told you, assume that the value of beta is very large, such that the value of base current will be approximately equal to 0. So in resultant, collector current will be approximately equal to the value of emitter current, and this value of alpha will become 1. I hope you all remember this relation I told already. In any question, by default, if there is no any data about beta and IB, you can proceed like this. So here in this question also, there is no any clear data about beta and IB. So I am assuming that the value of beta is very large and the value of base current is approximately equal to 0. So collector current and emitter current will become approximately equal. So the value of collector current will be approximately 1.875 ampere. Successfully we found one operating point. Now how will you find out the collector to emitter voltage? Sir, it is very easy now. How it is very easy? See that we know this voltage. Yes. Now you can simply just apply KVL up to this point. Let me show you that. See, I am starting from the top. They have given 50 voltage, 15, not 50. 15 voltage. Then I am replacing transistor by its correspondent collector to emitter voltage. We can call it as VCE. You know, after crossing the transistor, we got 0 voltage here. There is no point of forwarding further. Are you getting me? We calculated, no? Do you remember? What is the voltage at this point? This is 0 only. So we don't need to go further. Directly, if you observe, here I am having, once again, let us see, polarity I have been, did mistake here. Anyway, to avoid the confusion, I will draw the circuit like this. See there. Here we are having plus 15 voltage, and then we are having collector to emitter, then we are having 0 voltage. Now how will you find out the collector to emitter voltage VCE? Observe the positive plate, it is connected here, negative plate is connected here. So this is higher potential point, this is lower potential point. Now collector to emitter voltage, it is the difference between higher potential point minus lower potential point, that will be equal to 15 voltage. So we have calculated the value of collector to emitter voltage. So finally, operating point for this circuit, operating points of the circuit are, we know, that is collector to emitter voltage comma collector current IC. What is the value? Collector to emitter voltage is 15 voltage and the current is 1.875 ampere. We found this is called operating point or cutoff point. Now tell me whether the transistor is in active region or not. Sir, the value of collector to emitter voltage is, If you observe, it is greater than or equal to VCE SAT. It should not be equal VCE SAT. But this VCE you have to remember, it should be less than or equal to VCC. Actually, basically, so far I have written VCE is less than VCC only, because everywhere we will be keeping collector resistor RC. But the worst case is it may become equal to VCC. Worst case, I'm telling. Okay. Anyway, that's not a big deal. This condition will always be satisfied. You don't need to check. Your attention with this one only. You have to keep your attention with this one only. See that the value of saturation voltage is 0.2 voltage. So the value of VCE is greater than 0.2. So our transistor is in active region only. Our assumption is correct. So remember, the VCC could compare panila நம்ம region la idhirikku check பண்ணிருக்க மாட்டோம். I just told this condition also will be satisfied. But when the value of collector resistance is 0 and the opposite, see in the terminal 0 it's voltage, in that case that is the worst case. So worst case it may become equal to these things. Anyway, we don't need to be bothered about it. Your attention is with this one. Our condition is satisfied. Yes, our transistor is being operated in the saturation region only. You are correct. I hope you, sorry, not saturation region, active region. Sometimes our mind will be automatically going to unconscious state. Okay, so 1 minute. Let us move on to the next question. I'm drawing the next one. So the given it is transistor. This is collector resistance. Yes, we have one more resistor here, and here we have one more resistor. Like this, and these two terminal will be connected with the ground in this manner. This value they had given, that is 430 ohm resistor. Here they kept 5 kilo ohm resistor. Collector resistance RC, collector current is IC. This value is 10 kilo ohm resistor, and they have connected this with the supply voltage plus 15. Yes, and the direction of the current is given for the transistor. This is the direction. Don't get confused. This is collector current, they highlighted, and this is the direction given in the circuit. Then what is the question? The question is, for the circuit shown in the figure, the value of beta is very large. First conclusion, you know the meaning of beta is very large. If it is given like this, you know what to do. First, beta is very large, and base to emitter voltage 0.7 voltage, that is what given. Now the question is, what is the value of collector current IC, operating point? IC is dash. You can take your time, try to figure out the answer. And they told that the transistor is an active region. அவங்களே சொல்லிட்டாங்க, it doesn't matter. அவங்க கொடுக்காட்டி நம்ம அப்படிதான் assume பண்ணிப்போம். Finally, with the help of answer we can verify whether it is correct or not. So we don't need to be bothered about it. You can carry on, figure out the answer. What is the value of collector current? Got it? Anybody tried? Okay. Let me try from my side also. Listen. Whenever you are observing the base terminal, if the base terminal is directly connected with the voltage source with the help of one resistor, then there is no issues. Gita 0.01 ampere. Good. Let's see. See, 10 kilo ohm resistor is directly connected with the 15 voltage source. If you observe it carefully, so if you have only one resistor and that is directly connected to voltage source, then that is fine. Because how we can draw the base equivalent, not only base, see, equivalent circuit of the voltage source. Basically, practical voltage source can be drawn. How will you draw the practical voltage source representation? A battery with its internal resistance. Both will be in series. Yes or no? So this is the representation of voltage with the resistor. Practical voltage source representation. And you might have observed the same thing we did. Suppose in any circuit, sir, if this kind of representation is not there, then what should I do? இல்ல அப்படின்னா நீங்க இந்த ஃபார்மேட்டுக்கு கொண்டு வரணும். How can I do that? For that, we know we are having a simple superstar in our electrical circuits, that is called Thevenin theorem. We know Thevenin theorem will reduce the entire network. We will be finding the value of RTH and VTH. At last, after finding the value of VTH and RTH at the desired point, எந்த இடத்துல இதை நம்ம calculate பண்ணுமோ அங்க நீங்க calculate பண்ணிட்டு, then you can draw the equivalent circuit RTH. Anyway, for this question it is not required. For this kind of circuit it is required. நீங்க இதுக்கப்புறம் ஃபியூச்சர்ல வரப்போற ப்ராப்ளத்துல இந்த மாதிரி தேவைகள் வரலாம். So it's better to understand this type of circuit now itself. Let me explore. What I am telling now, let me repeat one more time. If you observe our transistor, basically transistor is having 3 terminals. It will be always having 3 terminals. Maybe your emitter is connected with the ground sometimes, or if it is connected with the voltage, whatever it is, if it is connected with the voltage source, either it may be ideal or practical. Ideal means they will give you this resistance at least 0. Practical means they will give you some internal resistance. Similarly, if you focus the collector terminal, they will be giving collector resistor plus VCC, or it will be directly given as VCC with a short circuit. Ideal case. Similarly, you have to, when you are focusing the base, either you can connect directly with VCC such that 1 voltage and a resistor, it will come directly. We can apply KVL. No issues. Sometimes what they will do is they will break this zone. Separately, they will give you the voltage. VBB they will give. In this case, if both are joined, then VCC and VBB both are equal. For the base also, we are applying same voltage. For the collector terminal also, we are applying same supply voltage. Sometimes they will break it and they will give these voltages separately. In that case also, you can apply KVL directly. But now if you observe the circuit carefully, what is this? They have given 2 voltages, sorry, 2 resistors. That is voltage divider circuit. They have given, whenever the circuit will be given like this, what you have to do is you must apply Thevenin theorem in order to draw the equivalent circuit. Draw the equivalent circuit means we need 1 voltage and 1 resistor, but in this case we are having 2 resistors across the base terminal. How can I consider இதுல யார் voltage source, இந்த இடத்துல எவ்வளவு voltage வரும், equivalent resistance எவ்வளவு வரும், எதுவுமே இப்போ வந்து தெரியாது. So now I hope you are very crystal clear with this. Base terminal should, whatever the terminal, it doesn't matter. You can keep 1 voltage source with a 1 resistor equivalently. If it is not given, then alternatively they will be giving like this only. That is the another format. Only 2 type of circuits will come. So far we have seen the first type. This is the another type. Sir, okay, conclusion. இப்போ இந்த மாதிரி கொடுத்தாரு என்ன சார் பண்ணணும்? So now we need the equivalent circuit across the base only. Yes or no? Base க்கு தான் இப்போ நமக்கு voltage problem வருது. So across the base only we have to identify the equivalent value. Let us take this circuit. Let me teach you how to identify the Thevenin equivalent. Very important and very easy too. Nothing is there to learn very big. So let me just show you how to do these things. Just keep your attention across the base terminal. If a base terminal எனக்கு வந்து VTH வேணும், Thevenin voltage வேணும், what will you do? What is the procedure to identify the value of Thevenin voltage? first. இப்போ Thevenin voltage வந்து நம்ம calculate பண்ணோம் அப்படின்னா first thing is I told you that we are going to draw the equivalent circuit across the base only. This is the base. It means base will going to drive the transistor. Yes or no? Can you please let me know? The supply voltage I can break it into two of 115 voltage and 15 voltage like this. Separately we can break. That is common voltage for both collector and base they have given. But tell me whether the transistor can be controlled with the help of base or not. Yes, sir, that is absolutely true. Transistor is a current controlled device, of course, and this transistor is under the control of base current only. If the actual base current will be zero, if it is not even microampere or nanoampere, it is zero, then transistor will be in cutoff region. It means it is not active. You cannot operate the transistor. We know this basics. So with the help of this basics, what I understood is if a person is driving a device, then this is called actual source. Then the device is simply called load. Can I call like that? Yes. So the transistor is simply acting as a load here. When we are trying to calculate the VTH here, இதுதான் ஒரே ஒரு டிஃப்ரெண்டான சர்க்யூட். யூ டோன்ட் திங்க் டூ மச் சார். அப்போ வேற மாதிரி வந்தா என்ன சார் பண்ணுறது, இப்படி அப்படி வந்தா பேஸ்ல இந்த மாதிரி தான் கொடுப்பாங்க. மேபி தே மே கிவ் யூ சம் டூ ஆர் த்ரீ மோர் ரெசிஸ்டர் சேர்த்து கொடுக்கலாம். ஏன்னா நீங்க Thevenin ஈக்குவலன்ட் கால்குலேட் பண்ணும்போது கொஸ்டினை இன்னும் கொஞ்சம் ட்விஸ்ட் அடிக்கிறதுக்காக. பட் திஸ் இஸ் தி ஃபண்டமெண்டல் அஜெண்டா. You have to treat your transistor as a load, calculate the VTH across this terminal. VTH எப்படி சார் இப்போ calculate பண்ணது? Just keep your attention. Let me redraw the circuit. They have given a 10 kilo ohm resistor. Base மட்டும் focus பண்ணுங்க. We have 10 kilo ohm resistor and a 5 kilo ohm resistor. Now I am removing the load according to Thevenin theorem. To calculate the value of VTH and RTH, step number 1, identify the load. Now here transistor is acting as a load, so I am removing the load. Identify the load point. Load identify பண்ணதுக்கு அப்புறம் while calculating VTH and RTH, we have to remove the load from the load point. So load is completely removed. After that, so this is how you have to do. Remove the entire transistor circuit and don't remove this voltage. In the voltage தூக்கிட போறீங்க. Supply voltage will be there. For your understanding only I am doing this actually. Okay, fine sir. So this is going to be 10 kilo ohm resistor and this is going to be 5 kilo ohm resistor. Now how will you calculate the VTH here? VTH is simply across these two terminals. We can connect like this. So if you focus clearly, what we can understand is the voltage is VTH is known as the voltage drop across the 5 kilo ohm resistor only. I am trying to measure. See, this is also connected with the ground. This is also connected with the ground. Then this positive plate, this plus will be reflecting here. This minus will be reflecting here always. So we can say VTH is nothing but voltage drop across the 5 kilo ohm resistor. Then what is the total voltage? Total supply voltage is 50. I am applying voltage division rule. Total voltage is 15 and voltage drop across the 5 kilo ohm resistor divided by total resistance offered by the branch. 10 plus 5, it is going to be 15 kilo ohm. So 15 into 10 power 3. It get cancelled out here and this 15 will get cancelled. In resultant, we found the value of VTH. This VTH is going to be the common base voltage now. Then what is the value of RTH, sir? How will you calculate RTH? While calculating the RTH, as usual, same procedure. Step number 1, identify the load. Transistor is acting as a load. Step number 2, remove the load from the load point. Yes, it has been removed. Step number 3, deactivate all independent sources. Now if you observe, only one independent source is there, that is 15 voltage. Voltage source will be replaced by short circuit. It means it will be connected to the ground when we are calculating RTH. If it is connected to the ground, see, this 5 kilo ohm resistor also connected to the ground only, 10 kilo ohm resistor also connected to the ground only. So these 2 points will become common. அப்ப நீங்க என்ன பண்ணிக்கலாம், just இந்த resistor அப்படியே fold பண்ணுங்க. Folding in the sense, இந்த ground ஒண்ணா connect பண்ணீங்கன்னா, அதுக்கப்புறம் shall I draw the resistor like this then? எல்லா இடத்துலயுமே இப்படிதான் வரும். ஜஸ்ட் நான் அந்த ரெசிஸ்டரையும் கீழே ஃபோல்ட் பண்ணியிருக்கேன், அவ்வளவுதான். கிரவுண்ட்ல கனெக்ட் பண்றேன். இதுவும் 10 kilo ohm, this is 5 kilo ohm. From where we are calculating the RTH? From here. This is going to be our RTH zone. Now if you observe the circuit carefully, 10 kilo ohm and 5 kilo ohm are connected in parallel from our terminal. So RTH is going to be the product of 10k into 5k upon 10 plus 5 will become 15k. 1k will get cancelled. 3 times of 5 will be 15. So the value of RTH, that is Thevenin resistance, will become 10 by 3 kilo ohm. We found the value of RTH also. This is how we are breaking the circuit. அப்போ டிரான்சிஸ்டர் இப்போ நம்ம திரும்ப எப்படி சார் வரையலாம்? Now tell me, VTH RTH நீங்க கால்குலேட் பண்ணி முடிச்சதுக்கு அப்புறம் திரும்ப என்ன பண்ணுவீங்க? VTH ஈக்குவலன்ட் சர்க்யூட் எப்படி வரைவீங்கன்னு கேக்குறேன். VTH then RTH and then it is connected with the load. இங்க load யாரு? Again bring back the transistor. டிரான்சிஸ்டரோட கம்ப்ளீட் சர்க்யூட் இங்க திரும்ப வரணும். யாரை ரிமூவ் பண்ணுமோ அதை அப்படியே திரும்ப உள்ள கொண்டு வரணும். So this will be connected to ground now. VTH, that is called base voltage. VTH we can call it as VBB. We know this value now. RTH, that is going to be base resistor RB now. Given it is NPN transistor, already they have given the data. It is connected to ground. Yes or no? Transistor is the complete load. 430 ohm collector resistance is not known. This is how we are redrawing the circuit. இதுக்கு நேம் எல்லாம் இருக்கு. இதை இப்படி பண்ணா அப்படி பண்ணணும். தியரிட்டிக்கலா நிறைய ப்ரூவ் பண்ணிருப்பாங்க. That blab story is not required to crack the question. That's why I am not entering into any theoretical part. You can directly solve the question. It is one of the application. இதுக்கு ஒரு நேம் எல்லாம் இருக்கு. அதை நம்ம அப்படிதான் ப்ரொசீட் பண்ண அப்படி எல்லாம் இருக்கு. Not required. Just you understand, right? This is how you have to break the circuit. So whenever the circuit will be given like this, அந்த சர்க்யூட் நீங்க என்னவா மாத்தணும், இந்த மாதிரி கன்வெர்ட் பண்ணிக்கணும். Then now see there, one voltage source, equivalent resistor, voltage equivalent resistor, that's all. Here voltage is not given, it will be 0 voltage. Fine sir. Shall we proceed further? அடுத்து என்ன பண்ணோம்? In the question they clearly told that the value of beta is very very large அப்படின்னு அவங்க தான் சொன்னாங்க. When beta is very large, then the value of collector current IC will become approximately equal to the value of emitter current. But we know the value of actual relation is emitter current will be the sum of collector current plus base current. But beta is very large in the sense base current will be approximately equal to 0 ampere. So I can say the value of emitter current will become approximately equal to collector current when base current will become 0. So conclusion is approximately the current flow through the base will be 0 ampere. Next conclusion. And they also told that the base to emitter diode voltage drop is 0.7. Yes or no? Now it's time to resolve the circuit. 1 minute. Yes. How will you resolve it now? We know the value of Thevenin voltage. How much it is? Thevenin is 5 voltage. Thevenin voltage is 5 voltage. Let me remove that things now. Because you understood all these things, we will directly substitute the values. Yes. So this voltage is going to be 5 voltage. Resistor value just now we saw, that is 10 by 3 kilo ohm. Base current will become 0. When base current is 0, what is the voltage drop across this resistor? Resistor voltage will become, that is RB. This resistor is called RB. Voltage drop will become 0 voltage. Why sir? According to Ohm's law, V is equal to I into R. When the value of I is 0, so 0 into R will become 0 only. Across this resistor there is no any voltage drop. Okay sir, that is not required now. Now can you please figure out the voltage across the emitter terminal C? The current flowing through the emitter is called IE. For the 430 ohm resistor, current entering point plus leaving point is minus. Then how will you write down the voltage drop? Okay, let me write. The voltage drop can be written as V is equal to I into R. Emitter current I into 430 ohm resistor. That is how we are writing the voltage drop for the emitter. Now I am going to apply KVL for this loop. Shall we apply? Yes, of course. Start from minus 5 voltage plus the voltage drop across the resistor will become 0. So that is useless. Next, here we are having plus 0.7 cut-in voltage. Next, emitter IE into 430 ohm resistor equal to 0. Minus 5 plus 4.7 will become minus 4.3. If I'll pass that 4.3 minus 4.3 to the right hand side, then it will become IE into 430 equal to 4.3. So from this I can take the value of emitter current IE is equal to 4.3 upon 430. Now what we are going to do? Nothing. If we cancel it, for that, in order to cancel this value, what I am going to do is, so I am writing like this. See, in the denominator we have 430. This 430 can be written as 4.3 into 10 power 2. Can I write like this? 10 power 2 means 100. 4.3 into 100 will become once again 430 only. Just to cancel it easily, such that 4.3 will cancel. This 10 power 2 will come to the numerator. So we can easily say that the value of emitter current is 1 into 10 power minus 2, or we can say 0.01 ampere. Yes, if emitter current is 0.01 ampere, then what is the value of collector current? Since collector current is approximately equal to emitter current, so that is also going to be 0.01 ampere only, sir. So finally, successfully, we got the answer for the collector current. Good. Now suppose if I want to know the value of collector current is known, collector resistor is not known. Right, so here we can't proceed further because the collector to emitter voltage VC also not given, right? That's why they have asked only collector current value. So there are two more unknown. Collector resistor also not known for us, and collector to emitter voltage also not known. It cannot be directly resolved. So this is sufficient. Anyway, we got the value of collector current. So the correct answer is 0.01 ampere. I hope you all understood how to resolve this question. Right. So let me drop the next question. Just wait a moment. Yes. So the next question is, try to figure out the answer by yourself hereafter. So given it is, let me draw the circuit first. This is the transistor, and here they are drawing, they have given one more resistor. Yes, and this is connected with the capacitor. This portion also connected with the capacitor, resistor R2, resistor R1, and the supply voltage is given as 6 voltage, and this is given, and the direction of the current is given like this. In the question, the amplifier circuit shown in the figure, the value of R1, R2 such that the transistor operating at, they told that the value of collector to emitter voltage is 3 voltage, and the value of collector current IC equal to 1.5 milliampere, 1.5 milliampere, whereas the value of beta also clearly given as 150. So this is when the value of beta is 150, they got the value of VC and the collector current as 1 milliampere. Now the question is, for a transistor, if guys, 1 minute, they are raising the value of beta from 150 to 200. They are increasing the value of beta from 150 to 200. Then what is the value of collector current IC, comma, collector to emitter voltage VCE? That is the question actually. Let me read the question one more time. In the amplifier circuit shown in the figure, the values of R1 and R2 are such that the transistor is operating at collector to emitter voltage is 3 voltage, collector current is 1.5 milliampere, and they have given under that situation the value of beta is 150, case number 1. After that, now they are raising the value of beta to 200 voltage. Then what is the value of IC and VCE? அப்போ இந்த R1 R2 பத்தி அவங்க கொடுக்கல. ஆனா என்ன சொல்லியிருக்காங்க அப்படின்னா, ஏதோ ஒரு ஃபிக்ஸட் வேல்யூ ஆஃப் R1 R2 வந்து நம்ம சூஸ் பண்ணோம். அந்த சூஸ் பண்ண வேல்யூக்கு வந்து கலெக்டர் டு எமிட்டர் வோல்டேஜ் வந்து 3 வந்திருக்கு, கலெக்டர் கரண்ட் 1.5 மில்லியாம்பியர் வந்திருக்கு, பீட்டா வந்து 150 கொடுத்துருக்காங்க. அப்போ பீட்டாவோட வேல்யூ நான் 200 மாத்தணும் அப்படின்னா ஐசிபிசி என்ன வரும் அப்படிங்கறதான் கொஸ்டின். ஃபர்ஸ்ட் லைட்டா யோசிங்க. ஃபர்ஸ்ட் R1 R2 கொடுக்கல, ஆனா ரிமைனிங் எல்லா டேட்டாவுமே கொடுத்துருக்காங்க. அப்போ அதை வச்சு நம்ம என்ன பண்ணலாம்? அதுக்கப்புறம் ஃபர்தரா பீட்டா வந்து 200ன்னு போட்டு திரும்ப நம்ம கொஸ்டின் வந்து எப்படி ஃபர்தரா மூவ் பண்ணலாம்னு யோசிங்க. ஸோ R1 R2 is fixed to some value such that அப்படின்னு சொல்லி proceed பண்ணிருக்காங்க. But R1 R2 கொடுக்கல. So indirectly what is the data given, அதை வச்சு நம்ம என்ன பண்ணலாம்? That's all. Just think for few minutes at least, try. Then I will be dropping the answer, don't worry if you don't get. Got the idea? Just think up to your maximum level. Try first. Try to figure out the answer. சார் அப்போ என்ன கண்டுபிடிக்கலாம் ஃபர்ஸ்ட் கொடுத்துருக்க டேட்டா வச்சு. திரும்பவும் VCE collector current and collector to emitter voltage வேணும் அப்படின்னா what we have to do? Just think in that way, then automatically you will get the clarity to proceed further. I hope. You might have got some idea, basic ideas. So okay, done. So what I am doing is, let me try to figure out the answer. First of all, one thing you must understand, suppose in any one circuit, if the value of beta is given and they are giving the value of R1 and R2, then supply voltage VCC is already given. If beta also given, R1 R2 also given, then we can easily identify the value of collector to emitter voltage and the collector current. Yes or no? They did the reverse engineering. Reverse engineering means usually in our previous problems at all, the value of R1 R2 they have given and they are requesting us to calculate the value of collector current and collector to emitter voltage. இதுதான் இந்த மாதிரியான கொஸ்டின் தான் நம்ம இது வரைக்கும் பார்த்திருப்போம். Now what they did simply, just they did the reverse process. Collector to emitter voltage கொடுத்துட்டு collector current கொடுத்துட்டாங்க, but just R1 R2 ஓட டேட்டாவை கொடுக்கல. First, case number 1 la, let us try to figure out the value of R1 R2. R1 R2 identify பண்ணிட்டு, then we will be going with moving forward to the new value. Shall we go? Yes. So we know when we are applying DC supply, I told that the capacitors are going to be open circuited. So you can remove the capacitor from this circuit. You don't need to be bothered about it. After that, collector to emitter voltage is not given. And I also told that if it is not given, you can by default you can take that voltage is 0.7. Next, if you observe, only one resistor is directly connected to the base terminal, so there is no point of bothering about it. I can call this current is base current. It will be traveling through resistor R1. Under the 6 voltage, it will be common. Here also we can keep 6. Here also you can keep 6. Okay, sir. Now apply 2 KVL. KVL 1 this way. KVL 2 straight away. Let us go with the KVL 1 first. KVL 1 means for the base to emitter terminal. I am drawing the circuit first. So we will be starting from the upper port. It will be connected with the ground. So here we are having minus plus 6 voltage. Then there is one resistor is called R1. It is connected with the transistor. You know how to cross the transistor through base to emitter. It will be replaced by 0.7 voltage. Then it will be directly connected with the ground. This is one way. The value of R1 is not known and the current through this branch is called IB. Yes. Now if we apply KVL, current entering point is plus, leaving point is minus, and this voltage drop can be written as IB into R1 according to Ohm's law. While applying KVL, how will you write the equation? Minus 6 voltage plus base current IB into resistor R1 plus 0.7 equal to 0. First conclusion. From this I can write further. Minus 6 plus 0.7. What will you get? Minus 5.3. If you pass the minus 5.3 to the right side, it will become plus 5.3. So I can write base current IB into R1 equal to plus 5.3 voltage. Our target is R1. I told you already they have given the sufficient data. Collector current is given. Value of beta also given. We know the value of collector current IC can be written as beta times of base current IB. From this I can say the value of base current will be equal to collector current IC by beta. Now what is the value of collector current here? IC value is given as 1.5 milliampere. Milli means 10 power minus 3 upon beta is given as 150. Now how will you cancel it? It will be 100 times of 1.5 only will become 150. So 1.5 divided by 150 can be replaced by 1 by 100, or I can write 0.01 into 10 power minus 3. It can also be further written as 10 into 10 power minus 6. Can I write like this? Just to figure out. I multiplied by 10 power 3 and I divided by 10 power 3 just now. So this 10 power 3 is nothing but 1000. 1000 times of 0.01 will become 10. Now in the denominator we are having 10 power 3. Bring it to the numerator. It will become 10 power minus 3. 10 power minus 3 into 10 power minus 3 will become 10 power minus 6. So I can say the value of base current is 10 microampere. You can also write it in this way. I am just showing, that's all. Now we found the value of base current. It is very easy to calculate the value of R1 now, because base current IP into R1 equal to 5.3. From this I can write the value of resistor R1 equal to 5.3 upon base current will be 10 micro. Micro means 10 power minus 6. So if you bring this 10 power minus 6 to the numerator, what you will be getting? It will become 10 power plus 6. Yes, sir. And it is very easy. If I will cancel it, 5.3 by 10 will become 0.53 into 10 power plus 6. We can further write it as what? 530 kilo ohm. Can I write like this? How I did this? 10 power 6 can be broken into 2 of 10 power 3 into 10 power 3. I am multiplying this 0.53 by 1000. So it will become 530. 1 10 power 3 can be written as kilo ohm. So the value of R1, we found the value of R1 is going to be 530 kilo ohm. One conclusion is over. Yes, sir. R1 is over. Now let us apply KVL for the second loop. That is for this one. R2, then collector to emitter voltage ground. So if we keep our attention with the second loop, again from the top, sorry, I have drawn it in a wrong way. Upper plate should be negative, right? Let me connect it with the ground. It should be negative, it is positive. Minus plus 6 voltage. Then we have resistor R2, that is unknown. Then we have collector to emitter voltage. You know how to replace it by. Collector to emitter voltage is given as how much? 3 voltage. They are only given. So this voltage is 3. Now if you observe carefully, that's all. It is directly connected to the ground. So the current that is entering here, it is called collector current. Current entering point plus leaving point is minus. Then the voltage drop can be written as collector current IC into resistor R2. Now if we apply KVL for this, you will be getting minus 6 voltage plus collector current IC into resistor R2 plus 3 voltage equal to 0. Minus 6 plus 3 will be equal to how much? Minus 3. So from this I can say collector current IC into R2 equal to plus 3, because left side it is minus 3, when it is goes to right side it will become plus 3. So the value of R2 will become 3 upon, what is the value of collector current? It is 1.5 milliampere. 1.5 milli means 10 power minus 3. From this I can say this will become 2. If you bring this 10 power 3 minus 3 to the numerator, it will become 2 kilo ohm. Did you observe? I am always telling that the value of base resistance is very high. See that we got 530 kilo ohm, whereas the value of R2 is 2 kilo ohm. So the value of R2 is 2 kilo ohm. We found the value of R1, R2 now. Now it's time to explore the new circuit. We know the value of R1, R2 supply voltage beta only. Second case, beta equal to 200. Take the same circuit now, but the new circuit will become, see, R1 we know, R2 also we know. Yes, here is our transistor. It is directly connected to the ground. This is our base terminal. This is for 530 kilo ohm, right? 530 kilo ohm, 2 kilo ohm. This is 530 kilo ohm, and this one is going to be 2 kilo ohm. Yes, this is plus 6 voltage. This is also plus 6 voltage. and we know this is called collector to emitter voltage, and this is collector current IC. We have to calculate these values, whereas the value of beta is given as 200, second case 200 voltage, and as usual this voltage there will be undoubtedly it will be 0.7 voltage only. It is fixed. New value of beta is 200. According to this value, we have to calculate the value of collector current and collector to emitter voltage. Can you proceed further now? How will you do this? So it is very easy. How will you do that? Once again apply KVL. The current that is flowing through the base, that is called IB. Current entering point plus leaving point is minus here. Again, as usual, the voltage drop will become base IB into 530 kilo ohm now. Yes or no? Yes, sir. So now you can proceed further with the same value. Beta is given as 200. Don't forget. Now it has been increased. Now first try to resolve this circuit. If I will apply KVL for this loop, what you will be getting? Let us try to solve this. Sir, you know how to solve this. It will be minus plus 6 voltage. So minus 6 voltage as usual plus base current IB into 530 kilo ohm. It can also be directly solved. நம்ம முன்னாடி ஃபைனல் ஆன்சர் கொண்டு வந்தோம் இல்லையா, அங்க இருந்து சால்வ் பண்ணலாம். Anyway, see, minus 6 plus 0.7 will be again minus 5.3. So it will give you base current IB into 530 kilo ohm equal to what? It will be 5.3. Kilo ohm means 10 power 3. I am writing it is 10 power 3. So the value of base current as usual it will become 5.3 upon 530 into 10 power minus 3, or I can say same 10 microampere only. There will be undoubtedly no changes. It is microampere, not milli. Sir, base current will not change. They are changing the value of beta. We know the value of collector current IC equal to beta times of base current IB. When the moment they are changing the value of base current, automatically collector current also will increase. You understand? Yes, sir. So what is the alternative way is, so from this I can conclude the value of base current is constant. The alternative I am telling. Alternative is, now you found the value of base current. From this you can easily identify that the value of collector current IC equal to beta times of IB, whereas the value of beta is 200 and the value of base current is 10 microampere. So it will become 2000 microampere, or I can say 2 milliampere. Yes, that is correct, sir. This is from this we found. Now if you apply KVL for the outer loop, the only unknown is we see there. If this value will become 2 milliampere, this current will become 2 milliampere. 2 milliampere into 2 kilo ohm. It will give you 4 voltage drop here. Out of 6 voltage, 4 voltage will be dropped across the resistor. Then collector to emitter voltage will become 2. Because 6 la 4 voltage inga drop it. Remaining 2 will be your collector to emitter voltage. So the answer is what? 2 voltage comma 2 milliampere are the new values. Yes or no? And I said what? Directly also we can calculate it. Directly means, sir, since the value of collector current IC 2 divided by IC1 can be written as beta 2 by beta 1 into base current is remain in both cases. IB1 and IB2 both are same, so it get cancelled. So directly you can write the value of collector current IC equal to beta 2 is 200, beta 1 is 150 into the value of collector current 1 is 1.5 into 10 power minus 3. Yes or no? Yes, sir. So it will become 100 times as usual. 100 times of 1.5. This will get cancelled out. See that directly you will be getting 2 milliampere. So after calculating the collector current directly, you can proceed further to calculate the value of collector to emitter voltage in this way. Like apply KVL for the outer loop, then you will be getting this value. So it's the thing is whether they are doing reverse engineering or for direct engineering, it doesn't matter. Reverse engineering na ஒண்ணும் கிடையாது, நம்ம அப்படியே ஆப்போசிட்ல பண்றது. யூஸ்வலா நம்ம ஃபார்வர்ட்ல எல்லா வோல்டேஜ் தெரியும், கரண்ட் தெரியும், அதை வச்சு நம்ம அதர் பேராமீட்டர்ஸை கால்குலேட் பண்ணுவோம். ரெசிஸ்டர்லாம் கொடுத்துருவாங்க. ஆனா இப்போ இந்த கேஸ்ல என்ன கொடுத்துட்டாங்க? ரெசிஸ்டர் கொடுக்கல, பட் அதர் பேராமீட்டர்ஸ் கொடுத்துட்டாங்க. எனிவே with the given clue what we did, we figure out the answer. So this is how we are solving the problem. Fine. Now I'm giving one more question. So the question is, wait, there is one resistor. It is connected with the transistor. Next, here this is one more resistor like this. This is going to be the base current, and this is going to be collector current IC. This is 1 kilo ohm, 3 voltage. Okay, this is the given data, and they told that assume collector to emitter saturation voltage is 0.2. Anyway, we know it is given in the question, though it is not given, we know that saturation voltage is 0.2 only. I have written it so many times. Beta is given as 50. Now the question is, minimum amount of base current is required to drive the transistor in figure to saturation region. I am repeating the question. Assume the value of collector to emitter voltage is 0.2 and the value of beta is 50. The minimum base current required, they are asking, minimum base current required to drive the transistor in figure to the saturation is dash. The minimum base current is required to drive the drive the transistor to the saturation region. Drive the transistor to saturation region is dash. Think and figure out the answer. Okay, that is the given question. Take it as the homework one. I hope you all understood what are the things that we did so far. Remaining things we will see in the next class. Don't try to stop with that. I told after